This is for open house for pre-AP chemistry. We offer during the summer time pre-AP chemistry as well, and we want to continue offering during fall semester as well. My name is Guvanch Murat Paitako. I hold a doctorate degree in computational chemistry. I taught many years AP chemistry, and I also prepared students for international chemistry Olympiads as well. All right, let's go ahead and get started then. This pre-AP chemistry during the fall semester will be offered on Thursdays, 6 through 8 p.m. Central Time, and it will start on September 12th and end on December 5th. There will be only one day there will be no class. That is November 28th. I believe that is a Thanksgiving break time. What are the requirements for this course is any high school student can take it starting from 9th grade, but there will be a math. We need some math background. Algebra 1 is preferred, but anyone in high school can take this course. And this pre-AP, what is the difference between AP and pre-AP? I will talk about that as well. Pre-AP is introductory chemistry course, and fall semester, I believe we are offering pre-AP chemistry A. Yes, that is pre-AP chemistry A. We will split the pre-AP chemistry into two semesters, A and B. A is the first one. As I said, high school is recommended, but 8th grade is also fine, but they should have a strong math and some science background. So our lecture will be online. That's why there will be no lab, but I will be using a lot of simulations, virtual labs while I'm teaching, so that students will understand better visually. So chemistry is very abstract. I understand that we are talking about atoms and all those stuff, and you cannot even visualize it. You cannot see them. That's why it's really hard for students to understand what's going on there. But thankfully, we have a lot of simulations available to help students to understand better. Description, we can read together. Chemistry is the study of connections between everyday world and the molecular world, the structure and interactions of matter. So basically, we are learning matter in microscopic level, and physics will be studying it on macroscopic. They are also studying matter and their interactions as well, but they are on a macroscopic level. They are studying the larger objects we are talking about. But when we talk about chemistry, teeny tiny, even we cannot even see them. It examines the smallest components of matter, atoms, and how atoms bond with each other to combine elements into compounds. So everything is made up of atoms. The way how they connect to one another makes different materials. Then it looks at chemical reactions, how energy is involved. So we will be also focusing on energy when the materials they react with one another, compounds react with one another. And then we will also talk about transfer of electrons. Actually, when you talk about chemical reaction, there is always transfer of electrons. Only electrons are transferred or shared, then chemical reactions are happening. And we will also, in the second part of the pre-AP chemistry, we will also talk about the reaction rates as well. So we will be with the pre-AP curriculum, we are covering half of the AP curriculum. So if students have a strong pre-AP background, it will be very easy for them to adapt to AP chemistry. AP chemistry is a bit more challenging. You can teach this chemistry course as not a pre-AP but regular chemistry course, then it will be different than the pre-AP curriculum. What's the difference between regular just chemistry course and pre-AP curriculum is pre-AP prepares those students to AP. The way questions are asked, the way content is explained while I'm teaching as well, I'm against memorizing stuff. Yes, you have to remember some stuff, but I'm against memorizing stuff because AP chemistry, You don't need to memorize anything. Everything that you need, equations and all those stuff will be given to you. You need to know how to use them, how to apply it. So that's how this pre-AP curriculum will be also. I will be aligning it with AP. So AP style teaching, you guys will be expecting from me, and AP style questions, and then topics as well. So we will not be wasting our time that is not necessary for AP. So that is also how pre-AP is aligned with AP. Chemistry is very vast. So many branches of chemistry we have. We will not be dealing with going into details and all those stuff, studying that is not necessary for AP chemistry. So we will be just this curriculum is focused on pre-AP curriculum, and that pre-AP curriculum will be aligned with AP curriculum later on. So what are the topics that students will learn in pre-AP chemistry A and pre-AP chemistry B? So 2 semesters we said. First semester, this one we will be focusing on in fall. Students will learn about chemistry, matter and change. Chemical change means chemical reactions. Scientific measurements, how you will measure. You will be given different tools and you should be able to measure it, or record your measurement in a correct way, so scientific way, so not randomly. We will also go into details those, and then we will be learning a lot about atomic structure, how electrons located in an atom, structure of an atom, where they are located, how they are located, orbitals and all those stuff. And then atomic structure continues again in unit chapter 4. We will be learning about electrons. So what atoms will be willing to lose electron and why. So you can teach chemistry just memorizing or always asking why it is doing that. So that is the background with this. When they learn about those, students in my class should be always asking why, and then they should be getting answer. Yes, because of this, because of that. When students learn that way, they never forget it. Otherwise, if you memorize something after the test, until the test, you remember some stuff, and then after this, everything is gone. But if you learn topics with the justification, so that is also another thing. Justify your answer. That is the AP style question. Yes, there is a true or false. Yes, you can say just getting it correct. It is true. That doesn't mean that you are getting point. You need to justify your answer as well. So that's how we will be teaching this course. Periodic table in detail, where metals are located, where non-metals are located. In a periodic table, there is groups, which is columns on the periodic table, and then there is rows, periods, we call it horizontal rows. And what does that group stands for? What I mean, the elements will have a similar properties if they are in the same group, and so on. We will talk about in detail. Trends in periodic table as well. Ionization energy, electronegativity, and so on. We will learn in details. And then we'll go into bonding, metallic and ionic bonding differences, ionic compounds, metallic bonding is happening in just metals, and then covalent bonding is happening with covalent compounds. What are their properties, differences, and so on? We will learn details of them. Lastly, we will be learning how to name compounds, and then we will stop there. We will pause there, or we will be done with pre-AP Chemistry A curriculum. I have designed this course, and then I have completely aligned it with the pre-AP College Boards. College Board is the entity who administers SAT and AP courses and AP tests. So I have aligned 100% our curriculum will be aligned with pre-AP curriculum there. All right, so what it looks like, we will have a virtual meeting. We will be teaching online. I will be using my tablet and all those stuff, so it will be pretty what I mean. I will be writing on a screen and then students can comment, but we will be using Momentum's Canvas where all the recordings will be posted after the class. Right after the class, you will have a handout and then there will be a homework assignment for that week. So students will have 1 week to complete those homework questions. For students, after so what was the deadline for this one? It is ending at December 5th. So after December 5th, another 3 months, all the resources will be available to students. So whenever students submit their homework, it will be automatically graded. Immediate feedback will be given to students. So Canvas is only for students, and then it will be sent to the students. Login credentials will be given to students 4 or 5 days before the class start time. Zoom link, students can also find the Zoom link for the lecture lesson as well on the Canvas. Okay, let's talk about chemistry then. What is chemistry? Chemistry is about everything in your real life. Chemistry is the study of composition of matter and change that matter undergoes. What's the matter? So definitions, we will be doing the definitions quickly, but most of the time with students, we will be solving problems. After introduction to the lesson, immediately we will start practicing. About chemistry, materials, chemists design materials to fit specific needs. For example, when you want to design a tennis racket, for example, you are trying to get a material that is lightweight and it also needs to be very sturdy as well. So you might not get from nature immediately that material. You might not find that is very lightweight and that's very durable or hard as well. So you have to mix materials to get that property. So chemistry is doing that, chemists are doing that. Mix materials to get specific, to design the materials that is specific needs. So rubber, for example, you might have a rubber, but you can make it harder, softer, very flexible, less flexible, and so on. Chemists play an essential role in finding ways to conserve energy, or fireworks, for example. That's also energy, but it's also, you can convert it into different colors as well with a chemical reaction. So that is also energy. Light is also energy. And then how, from which level of electrons excited to higher energy level, and when they are coming back, so depending on which energy level they are jumping, different colors you will see. And then producing energy, burning of coal, petroleum, and natural gas. We will be writing equations for them, and then we will be calculating energy. How many grams of this substance will produce how many joules, kilojoules of energy. And then also different chemists are also dealing with batteries as well nowadays. Batteries are where you can store the energy for later use, from watches to computer batteries to cars nowadays. Medicine technology, biotechnology. So especially my degree was for PhD was computational chemistry, where I have done there are computer simulations so that you don't have to do the chemistry lab in the lab, chemistry mixing compounds in the lab for the experiment, but you can simulate exactly in real life where those reactions will happen or not. So if you guys have noticed during the COVID time, the drug was synthesized and in the market in a very short time, and then many people were, how it is possible, but our computers computational power was allowing that to do. What I mean, those calculations, instead of trial and error, hundreds of experiments, you can minimize it to 4 or 5, and then that speeds up the time how you can produce the medicine drug that is needed for the patient's treatment. So that is the biotechnology is there. Computer and the chemistry is also merged, computational chemistry. So other use of chemistry is agriculture, environment, and universe as well. There are different types of branches of chemistry. We said organic chemistry, carbon containing or living things, especially. Inorganic chemistry, non-living things. And then biochemistry, biology and chemistry related. Analytical chemistry usually focuses on the composition of matter. If you are in a forensic science, for example, doing or blood tests and all those stuff, those are analytical chemistry. You are always measuring something. Physical chemistry, the area that deals with mechanism, the rate and energy transfer. So those are physical chemistry topics. All right. So in chemistry, we are doing experiments. And when you are doing experiment, so you cannot just jump to an experiment. You have to observe first. This is a scientific method. You have to observe this is happening, and you want to explain how it is happening. So you might come up with hypothesis then, okay, maybe because of this, it is happening. You have your own explanation, and you want to test it. So experiment is kind of test. You are testing it. And if your experiment, what I mean, verifies that your explanation, which is hypothesis, your explanation is correct, you are repeating that many, many times, all the time it is coming correct, then that hypothesis, your explanation, may become a theory. So theory is many, many times tested and always it is proven to be true, then it is a theory. Hypothesis could be correct, could be wrong. Hypothesis is, but that is before that is your explanation before you start with experiment. Once it is verified with an experiment, it can become a theory. But theories, what I mean, many theories that are considered to be correct before, nowadays they are proven to be either there are some flaws, it needs to be corrected, or completely wrong as well. It can be. It depends on the equipment that you are using. So at those times there was not that precise equipment, and your experiments were also based on that flawed or not precise equipment. Therefore, you assume that that was correct, but nowadays it might be slightly different because you have more advanced equipments. But there will be a difference between scientific law and the theory. So scientific law, you don't have to explain something for the law. You observe. So if you have a apple in your hand, and then if you just leave it alone, it will drop. Well, that's a gravitational force. So you don't have to explain that. There might, yes, we are trying to explain with gravitational force, but there is no need to explain, or there is no need to be proved. So it is always proven, and it is a law. No need for explanation for that. When you drop a apple from your hand, it will drop. What I mean, it will reach to the ground. It will not stay on the air. So we will learn in detail hypothesis and theory as well. What's the difference? Okay, time is okay. So we will also learn in detail the differences between solid, liquid, and gas phases. So in a gas phase, particles are far away from one another, and there is very limited attraction in between them because they are far away. But in liquid and solid state, they are very close to one another, closely packed. The closest packet will be in solid, and liquid is also close, very slightly compressible, maybe not compressible liquid as well, but somewhat those particles are moving freely somewhere. They can flow or slide past one another. But in a solid state, particles are in place. They are staying in place. So in order to convert from solid to liquid, you have to melt it. You are disrupting that crystal structure there. And then only the crystal structures are crystal structure. The energy that is holding that crystal structure is broken. That means still there is interaction in between them. They are not completely far away from one another. So compressibility, we will be discussing, and then also other properties, density, comparing their densities, and so on. So how you can change from one to another? That's the temperature, increasing heat or absorbing heat. So when it goes from left to right, it is absorbing heat. Temperature is rising. When you go from C to A, from right to left, temperature decreases, heat is released. Okay, states of matter, solid, liquid, gas. When you convert from liquid to gas, it is evaporation. Sometimes we call it boiling. So boiling and evaporation, kind of, there is a difference as well. If you leave water at room temperature for a long time, if you have a spill of water, small amount of water spill on your desk, let's say, and after maybe 2-3 hours, that water is not there, but your room temperature has not reached 100 Celsius degree where the water is boiling, never. Then what? It is not boiling, it was evaporating. So those particles were separating from one another, water molecules were separating from one another, and it was evaporating. And the opposite is from gas to liquid is condensation. Freezing and melting is also opposite of one another. And gas to solid, some materials at room temperature, or they are not boiling, or their boiling point and melting point are very close to one another. You don't see them boiling. You don't see the liquid state. So it goes directly from solid to gas state. That is called sublimation. Iodine is one of those materials that is doing that. And if you put a dry ice, which is carbon dioxide, solid carbon dioxide at room temperature, you won't see also liquid carbon dioxide. It will be immediately forming a fog. As I said, I will be using a lot of simulations in my class. And if you guys have questions about pre-AP chemistry or topics, please feel free to ask. Our office hours will be Monday through Friday, 2 to 6 p.m. And number is there if you want to reach to office. And Saturday and Sundays, it will be 12 to 4 p.m. But it's better to reach through email, even if you evening time out of the office hours. If you email, we will be responding your email maybe next day or same day. Thank you all. If you have questions, please let me know. Okay, there is a question. Let's see. You may write on a chat box or please unmute. So will there be a test? Okay, will there be a test? No, there will be no test. But if you guys interested in taking test at the end of the unit or at the end of the, we can administer that, but there will be only homeworks assigned to you every week about that topic that you have learned. Any other questions? How big is the class? That's a good question. So it depends. I believe there is a maximum number on the for each lesson. I believe it is about 10 to 10, I believe. But usually for chemistry, I believe there is less interest, maybe. That's why about 5 students, 6 students, like that. But if you are there to learn, please utilize all the ways you can ask questions during the class time for students, especially. If you are shy, you will be given option to chat directly with the teacher, so others will not be able to see your chat, what I mean. So, and teacher will not reveal who is asking that question. There is this question, and then we will explain whatever it is. So you guys need to be very relaxed and ask anything that is related to that topic comes to your mind immediately. What's the cost of the class for? Okay, I believe around either $6.99 or something like that. Let me check that really quick. It is on our website, so let me open that website really quick as well. Okay, so that is Momentum Learning. Momentum Learning Center, let's say, and then not that's a Facebook page. There should be a, I believe this is the Momentum Learning. Hopefully this is our website. Okay, org, not com, sorry. Momentum Learning. And then if you look into the curriculum and then registration for the fall, for example, registration instructions, fall 2024 in registration, and courses we need to say summer, fall, online. This will be ours will be online, and high school, in high school category. So we should be having courses there. Algebra, Python, Java. Pre-P Chemistry A is there. The fee is $7.49. I believe they are saying if you pay early, something discount code is also there, but I think that date has passed, sorry. So it is $7.49.
Does this class designed for some kids already have a chemistry knowledge, or it's okay for it's like a zero knowledge for this part?
Thank you. Yes, some science background is good. If they take it science class during the middle school, that is enough. No need any further chemistry background. There's no need chemistry background. Whatever they have learned during this science class in middle school, that is enough. But we will be reviewing what I will be teaching. I will not be assuming that you guys know everything and then I will continue from there. No, I will be explaining what's going on. Even if you are first time you are seeing that will be clear.
Thank you.
And I can give some example for the simulation that I'm using. So, for example, I will be using this simulation website a lot. For example, this is just molecule shapes. For example, we will be learning, and then they will know exactly what type of shells So what happens if you have two electron groups around central atom? What will be the shape? We will be using these and explaining what I mean. 180 degree. So Vesper theory we will be learning, and then they will be repelling one another maximum far away possible. So since you have a 360 degree available, they are maximum far away from one another. It is 180 degree, and then the shape will be linear. But if you add another bond, then that 360 will be shared in between, shared with three angles, which is 120 degree each. And then you also say that it is a trigonal shape, but with a planar. So all those trigonals are in the same plane, But what if you add fourth one, for example? It's not anymore in the same plane they are, and available. It's a 3D shape. That's not a 2D shape anymore. And it is a tetrahedral, means four faces you have, equal faces, four equal faces. One face will be these three connecting to one another. Another face is below, connecting to one another. Another face will be on this side, and the last face will be on the back, these three. So I will be drawing them, drawing as well while I'm teaching those. So let's see. Am I sharing my screen? Yes, I'm sharing. And okay, I was looking for this one. So I'll be drawing and helping students to understand better those. Any other questions? I believe there is another question there. Okay.
I have one more question, if you don't mind.
Go ahead.
Yeah, thank you for sharing this website. Except this website, do you have any like resource or any material you suggest us to study?
So this website has simulations. It's not the only simulation website I will be using. Some other websites as well. These are the resources I will be using to explaining, but I will be giving them handout, what I mean, with all the links to these websites and all those stuff. Students will have access to that. For example, I will be also using online, free online chemistry textbook as well. So that's a LibreText, it's called. So you are not limited to use these. You can purchase a hard copy textbook as well, but it's already there, what I mean. Anything that you want to learn about chemistry, it is there. So it's not limited to chemistry. But chemistry textbook is also there. PDF format, or you can use the online version. Whatever topic you need help with, you can search online and it will give add it to you, send you to that page information that you need. So I'll be sharing all those links where I'm, what I'm teaching, and where they can find practice questions. And then another resource that I will be using will be a CK12 one. So we will be practicing. There is also simulations. There is also videos available, reading parts, but mostly the practice parts available there. So those are some of the resources that I will be using.